Alright, now this night we'll be working on a topic known as work, energy, and power. Now, to understand work, energy, and power, I'll be giving a question right now, but sometimes you just have to understand the principle behind the topic. You understand? Now, what is work? We say a work is done. Are you paying attention? When a force is applied over a certain distance. Please sit up properly. Sit properly. I don't want you to be resting your head as if you're not serious. Now we say work is done when a force is applied over a certain what distance. And if you apply force over a certain distance, work done is equal to force times distance. Are you getting me? And we say the SI unit of work done is what? Joules. That's capital letter J. Now, the question now boils down to the fact that we know, please write these things, where force is equals to mass times acceleration. I mean, therefore we can say that work done, this implies that work done is equals to what now? Instead of writing force, we can say it is MAD, MAD. Are you getting that? Now it means work done is equals to mass times acceleration times what? Distance. Normally in physics, distance is not written as D, it's written as small letter s. So for proper understanding, it is best that as a student, you should know when to represent these things. Now, if we know work done can be this, we also know very well that acceleration is equal to velocity over time. It means that I can say that work done is equals to mass times velocity times distance all over what? Time. You see the formula is expanding. Huh? All these formulas that we have written here, this one, which is the first one, this one, which is the second one, and this last one, you can use them to calculate for work done when you are working, when the work done is on a straight line. You understand? That's the only way you can make use of these formulas. Have you copied them down? Please do. Copy them in your notes. Because at the end of the month, I'm going to ask you questions. That these questions, that this work is really going to be, this work you copy in your notes now will be important for you. Is that clear? Now, if we know that work is force times distance, because we say work is said to be done when a force is applied over a certain distance. The SI unit of work done, according to physics, is the joules. Then, we know that force is equal to mass times acceleration. Then, work done will be equal to what? Mass times acceleration times distance. Now, we also know that acceleration is velocity over time. Then, work done is equal to mass times acceleration, mass times velocity times distance over what? Time. So you can use any of these three formulas to calculate for work done on a straight line. Is that clear? When the work is done on a straight line, you can use any of these formulas to solve them and you get your answers right. Please hurry up. I'll be wiping the board now. And leave it. Where's my board wipe? First thing you used to write the board just now.
Yes.
Hey, wait.
I'll say.
Now, manage with me with my small board. With time, we'll get a bigger board for better understanding. You have written all this. Now, you can still be asked questions like this. What is the formula for work done when the force is applied at an angle? It can be applied at an angle to the horizontal or to the vertical. What will you do? When we say horizontal, this is horizontal. When you have things like this, horizontal line. Vertical, this is vertical. Are you getting me? So the lines that runs from y-axis in your graph is vertical line, while the line that runs through the x-axis is the horizontal line. If you know you are feeling sleepy, please stand up on your feet. Stand up on your feet. Don't make me make you stand up. Now, we can also find when, or let me write it, how to find work done at an angle to the what? Horizontal. How do you do that? We say that work done is equals to force times distance cos theta. Are you getting me? Work done is force times distance cos theta. Well, please write as I'm writing because I don't want to waste time and be cleaning board and waiting for you. Well, to the vertical, work done is equals to force times distance sin theta. Now, people will be wondering, I've never seen this formula before, sir. Yes, that's because you have not been given questions that will jiggle your brains into some certain things. If I ask you, a picture frame that is placed on the wall and a rope is tied to that picture frame to the vertical, if the picture frame will be hung on that rope, calculate the work done that to take the work done to make that picture frame to slide down to the ground in the vertical. You'll be wondering, sir, what kind of formula is that? What kind of question is that? Yes, any question can come up. You can see another question like this. A child drawing his toy with a rope by his hands, and then they will say if he apply a force over a certain distance and the rope is at so angle to the child, calculate the work done in dragging the toy. Are you getting me? Then you'll be wondering, I don't understand. How does they work? No, you need to understand, because these formulas are important. How many formulas have I given you for work done now? 5. Are you seeing it? 5 of them. On your own, if you check your textbook, you might see only 1. But we are bringing all these things and exposing them so that you should understand that everything, questions can come from anywhere when it comes to work done. And there are so many other things you can use to calculate work done. Stand up on your feet. Now, if you look at what we have here, we have had work done to the horizontal and work done to the vertical. If you are given any question at all on work done, these few formulas that I have given you on this board can handle them. All you have to know is your parameters. And when you know your parameters, you can solve work done in any place, especially whether it is on a straight line, it's tilted at an angle, or whatsoever. Is that clear? Is that clear? Where are you going? You're about to leave the class. You cannot tell me. That should not happen again. Oh. You tell me with your brain, Abi, because you don't have mouth to open and say, "Sir, I'm about. Please, we'll see what I want to do." Now, this you have seen for work done is all it is. Somebody will say, "Sir, wait, oh, that's not what my teacher taught me on work done." Yes, work is said to be done when the distance is covered. If somebody carries a bag of garri or bag of cement on his head and is standing in one spot, the truth is that person is not doing any work. That's the basic truth. That person is doing nothing according to physics, as far as he's standing in one spot. Are you getting? But if somebody picks a bottle of cup or a bottle of glass or whatever, a glass cup, and is moving up and down, is covering a certain distance, and is with that particular load, that person is doing work. Why? Because he's covering a distance with that. Is that clear? We can calculate for work done in different machines because we are covering what distances and forces are being applied. Are we together now? Are we together now? Now, that's for work done. Before we start solving questions, let's talk about energy and we'll talk about power. By the time we finish those, you'll be able to go to any question in your textbook and solve them. Now, for energy, brother, what is energy?
The ability to do work.
Please speak out so that I can hear you.
The ability to do work.
So we say energy, this is the ability to do work. Now, energy is not different for work, but the difference between energy and work, when something is an ability, does not mean the thing must always be moving. Are you getting me? That thing has the potential to be in one place. Are you getting me now? That's what energy is. Everything that exists on planet Earth possesses a certain kind of energy. Everything. Whether it's a wood that is just lying on the floor, it possesses a certain kind of energy because it can be used to do work. Is that clear? Now, for energy is also measured in joules. So we say that the SI unit of energy anything you see me write on the board, make sure you put it down on your notes, even though it's rubbish. The SI unit of energy is joules. Capital J. Now, there are two types of energy. Let me call them the types. What are they? The PE and the KE. When you say PE, what do you mean? We mean potential energy. KE, we mean kinetic energy. When an energy is said to be potential, it means it is static. If you don't understand the word static, it means it is not moving. It is in one spot or one position. That is a potential kind of energy. Is that clear? Then, when is an energy said to be kinetic? it means the energy is what? Dynamic. Dynamic means it is constantly moving. Are we together here? So for potential energy is energy that is stored, energy possessed by a body that is not moving. That's potential. But kinetic energy is the energy possessed by a body that is constantly what? Moving. Are we together here? Are we together here? This is the difference between the potential and the kinetic energy. But in terms of formula representation, potential energy is equal to mgh. You can see what's mgh? Mass, gravity, and height. Potential energy is equal to mass times gravity times what? Height. Are you getting me? Well, in terms of mathematical representation, kinetic energy is 1/2 mv squared. Now you can see these two formulas. One has velocity. Velocity means it is constantly is the reason why kinetic energy is moving. Then this one is mgh. Is an energy with respect to gravity. So the object is always in one spot or in one position. You understand now? Now, I can write these formulas in different way. We know that acceleration due to gravity is acceleration. I can write it as mgh. Sometimes it can be mah or mas. It is still energy. Is that clear? Therefore, kinetic energy here is half mv squared. We know what velocity is. Half mv squared can also be velocity is distance over time, right? It can be ms squared over 2t squared. The same thing. Displacement over time. Most times we call it distance over time is speed. Because why? Speed is a scalar quantity. Velocity, displacement over time, vector quantity. But both of them have the same dimensions. So when we are calculating, most times we just the displacement, distance. But we know when we say distance in terms of velocity, we are also talking about what? Displacement. So this is a formula for mechanical energy, for kinetic energy, and this is also a formula for kinetic energy. Now there are different forms of energy. Let's write it. But before we know each of these forms of energy, there is a particular law that you must know when it comes to energy conservation or energy transformation. It's called the law of conservation of what? Energy. What does that law state? This law states that energy can neither be created nor destroyed. This law is also known as the law of thermodynamics. The first law of thermodynamics. Are you getting me? This is also like law of conservation of matter in chemistry. But let's use energy here because we are dealing with energy. The law of conservation of energy, please write it down, states that energy can neither be created nor destroyed, but can be converted from one form to another. Is that clear? The law of conservation of energy states that energy can neither be created nor destroyed, but can rather be converted from one form to another. That's what energy is. Now, if we know that energy can neither be created nor destroyed, do you create energy? No. But it can be converted from one form to another. I hope you are learning. If you have written the law of conservation of energy, let's talk about forms of energy. are the various forms of energy? It means forms in which energy can be converted or transferred to what they can be. We said here we have mechanical energy. We have electrical energy. Number 3, we have heat energy. Heat is also known as thermal energy. Number 4, we have chemical energy, right? Number 5, we have what? Atomic energy. The one you call atomic, I prefer to call it nuclear. Nuclear energy. Number 6, you have what? Light energy. Let's call it solar. Solar energy. Energy from the sun. Is there any other one we have not mentioned? Since I mentioned almost all, if there's any other one we have not mentioned, you can find them, and please let us know in the comment section. Now, if these are the various forms of energy, you can see that this energy exists in different machineries or in different bodies. Mechanical energy, you can see mechanical energy in things like your generator, your cars, your trains, your aeroplanes, and whatever. Most machineries, tractors. Electrical energy, you can see them in your household appliances and so on. Heat or thermal energy, you can see heat or thermal energy in in your cooking stove or your gas, or even in the engine of a car. There is heat there. Then you see chemical energy. Chemical energy is not all liquids that can produce energy. You can see fuel, kerosene, and the rest. They have the ability to produce energies, but what they can do during combustion, other liquids cannot do the same. Then you can see nuclear energy. This one is one of the most reactive of them all. I said stand up on your feet, and I'm serious about it. Nuclear energy is one of the most reactive. Then the next one, you see solar energy. You have heard of solar panels and solar systems. You've heard of these things. Now, why do we can harness energy from the sun to get us solar energies? Now, all these energies have their various applications. Note, we don't create any of them, neither can we destroy any of them. But we can convert them from one form to another. Most of our devices are energy converters. Your electric iron converts electrical energy to heat energy. Your what's it called now? Your hot plate also converts electrical energy to heat energy. Your car converts both chemical energy into mechanical energy and also to heat energy during the braking system. You understand that now? Now you can see that in the energy transformation system, or in the forms of energy, you have various, and they are numerous. A lot more will be discovered in no time. Is that clear? Is that clear? Yes. Please write this down. Now let's talk about the next one. Let's talk about the next big thing. Power. Are you done? Are you done? Be fast, please. We'll solve questions on this. I just drop in the explanation first. Power. Now, what is power? So our layman's understanding of power We say power is the rate of doing work. That's what power is, and nothing more than that. You say power is the what? Is the rate of doing work. It means if you have two childs, let's say one of them is 5 years old and the other one is 15 years old, and you ask those two children to carry, let's say, 5 liters of water each over a street of 10 meters, which of them do you think will get to the end of the street first? I'm asking you a question. The older child. Why? Because common sense will tell us that that child has more power than the what? The younger child. It is not, we are just using common sense, but according to physics, it is the time that that child used to do the work that matters to us. If your machine will do a particular work for 5 minutes and another machine will do that same work for 2 minutes, which of these machines have more power? It is the one that will do the work for 2 minutes. Is that clear? Is that clear?
Yes.
So we say power is the rate of doing work. Therefore, let's see the mathematical representations, because that's the most important thing on these topics. So what is the formula for power? We say power is equal to work done over what? Time. Are you seeing that? That's what power is. Power is work done over time. What's the SI unit of power? Write it down. The SI unit of power is what? Watts. Capital letter W. If you check it, you will now discover that your light bulb, those olden days light bulb, even the ones they sell to us nowadays, you see 10 watts, 100 watts, 200 watts, and the rest. Check your refrigerator, you will see sometimes 1500 watts, 500 watts. Check your electric iron, they put these things in watts so that you can understand that these devices, they have power ratings. Is that clear? So power, we say, is measured in what? Watts. Are we together?
Yeah.
Another formula for power can be power is equal to energy consumed over what? The time. So the total energy consumed over the time taken can also be what? Power. Is that clear? So when you want to calculate anything when it comes to power, you understand that, now, if you look at this formula very well, let me bring out some certain things for you, because formula is about to start transforming themselves now. I hope you have written this. You want to start transforming themselves now. Watch this. Watch this. We say power is equals to work done over time, which is force times what? Distance over time. Do you know that distance over time is same thing as speed or velocity? Are we together now?
Yes, sir.
Now, if this happens, it means that V is equals to S over T. So therefore, I can say that power is equals to what? Force times what? Velocity. This is another very important formula to note in these calculations. Are we clear? Are we clear now? Now what you do, after you have written all these, go over them. Go over them. In our next class, we'll be solving questions pertaining to work, energy, and power. Any questions?
No.